In this video, we'll be solving quadratic equations, and there's several different ways that you could solve quadratic equations. One of the ways is what's called factoring, and then we use what's called the zero product property. The zero product property. Another way is what's called completing the square. A third way would be the quadratic formula. A fourth way might even be to look at a graph. So we're going to focus in this video on factoring and on the quadratic formula. And there's lots of other ways. There's other ways clearly that you can do it, but it would be too long of a video. So let's work on the factoring for letter A. So in order to factor, you could go back and watch a different video on factoring. It's a separate skill in itself, but we'll go over it briefly here. Whenever you're taking a quadratic, and I know it's quadratic because it's x squared, so quadratic means you have a variable squared. The structure of using a rectangle like this is an area model. The first term, x squared, is going to go in the first box, and the plus 16, so the 16 is going to go in the last box. And it's a puzzle. I like to think of it like a puzzle, where this diagonal, if I multiply it, x squared times 16, that is 16x squared. This diagonal, if I multiply it, will also be 16x squared, even though they're blank. I don't know what they are yet, but I know they multiply to 16. And then they both have to add to negative 10. To negative 10x. These two blanks add to negative 10x. The blanks, in quotes, add to negative 10x. So we could start to brainstorm things that multiply to 16. Things like 8 and 2, or 4 and 4, or 16 and 1. 8 and 2 add to positive 10x, but not negative 10x. So how about negative 8 and negative 2? So this is just a brainstorm list. Negative 8 and negative 2, that would work, and they both have to be x. So this would be a negative 8x and a negative 2x. That adds to negative 10x, and it multiplies to positive 16x squared. I'm going to erase my brainstorm list now. That's just kind of scratch paper. Now finally, what I'm going to do is I'm going to look, x squared has to be x times x. This right here, I know this side is x, so this must be minus 8, so that x times minus 8 gives me minus 8x. Similarly, this is minus 2, so that x times minus 2 is minus 2x, and then negative 8 times negative 2 is positive 16. I call it the quality control check. So I just rewrote this quadratic as x minus 8, x minus 2. So that quadratic is equivalent. These are equivalent forms, and it still equals 0. That is very important. It has to equal 0. So I can use this thing called the zero product property. If you invest some time and you try to think through two numbers that multiply to 0, well, let's see, 4 times 0, 2 times 0, negative 8 times 0, anything times 0, even 0 times 0, if two quantities multiply to 0, at least one of them must be 0. That's the zero product property. There's no way you can multiply to 0 unless one of your numbers is 0. So that means x minus 8 could equal 0, or x minus 2 could equal 0. One of these two things that are being multiplied together must equal 0 if the whole product is 0. Well, x minus 8 equals 0. I could add 8 to both sides. That would get me x equals 8. Or add 2 to both sides. I get x equals 2. And it turns out that's my answer. X equals 8 or x equals 2. Let's try this factoring again, and maybe we'll do it a little bit quicker. Not every quadratic can factor, so I want to caution you. So let's try. Let's start and see if this will factor. You can always start there. So I'm going to make my area model rectangle. The first term, let me keep the colors consistent. The first term, 2x squared, goes in the first box. The minus 27 goes here. That diagonal is 2 times negative 27, which is negative 54x squared. So this is negative 54x squared. And they have to add to negative 3. So let's see, what multiplies to negative 54? We'd have 6 times 9, and if it's negative, one of them's got to be negative. Well, that would be, if I added those, I would get positive 3. So let's just switch the signs. How about 6 times negative 9? That gives me negative 54, and it adds to negative 3. So this combination works. And they have to add to negative 3x. So these are x terms. So I have a 6x and a minus 9x. Erase my scratch work again. The mere fact that I found a pattern that works means this does factor. If you couldn't think of a pattern that worked there, that would be an indication that it doesn't factor. Okay, 2x squared has to be 2x times x, but where do I put the 2x? So notice this column right here, I have a 2 and a 9, and the 2 and the 9, they're not both even, whereas the 2 and the 6 are both even numbers. So I'm going to put the 2x here and the x here, because 2x times x is 2x squared, and then 2x times something is 6x. So that must be a 3, because 2 times 3 is 6. So 2x times 3 is 6x. X times something is minus 9x. So x times minus 9 is minus 9x. And then quality control, negative 9 times 3 is negative 27. So this is now factored. We have 2x minus 9 times x plus 3, and it equals 0. Using the zero product property again, this thing could be 0, or this term, this thing could be 0. So I could have 2x minus 9, that could be 0, or x plus 3 could equal 0. In this one, I would just subtract 3 from both sides, and 0 minus 3 is negative 3. So x equals negative 3. In this one, I would do plus 9 on both sides. So I would get 2x equals 9. Then I would divide both sides by 2, and I would get x equals 9 over 2. And 9 over 2 is 4.5. So I have x equals 4.5, or x equals negative 3. Letter C, if we try to do this factoring thing again, you're going to find out that it doesn't work for letter C. I'll save you the effort here, and in terms of being able to do another method, the quadratic formula. So the quadratic formula says, take a quadratic that looks like this, ax squared plus bx plus c, and it has to equal 0 because it's related to this zero product property again. I have coefficients a, b, and c. So in this case, a would be 3, b would be 24, and c is minus 33. And the solutions to this quadratic equation can be, it's formulaic. It can be given by a formula. And it looks kind of crazy the first time you ever see it. It's negative b plus or minus, because there's two solutions. Square root of b squared minus 4ac all over the quantity 2a. Okay, so when I'm doing this, I like to do the b squared minus 4ac as a separate line. And one thing you can do to save yourself a lot of headache is just to put everything in parentheses. So b is 24. In this example, b is 24 squared minus 4. I'm going to put a is 3. and c is negative 33. So this quantity b squared minus 4ac, that is 972. And again, I did that because that's a term that I'm going to need. So now my solutions are x equals negative b, so b is 24, so this is negative 24. It changes the sign. Plus or minus square root of 972 all over twice a. So if a is 3, twice a is 6. Make that a better looking 6. So this is representing my two solutions. I have x equals negative 24 plus root 972 all over 6, or x equals negative 24 minus root 972 over 6. There's several strategies to enter this in the calculator. If you have a graphing calculator that is relatively new, one thing that's really nice is to use the fraction capabilities. There are these function keys on a graphing calculator like this. There's F1, F2, F3, F4, F5, and they're green. So I'm going to hit the green button and hit F1, the first function, and that's my fraction menu. And I can pull up a fraction, numerator over denominator. This is just a really nice way to enter these. So I'm just going to enter it exactly as I see it now. Negative 24 plus second square root of 972 all over 6, and hit enter. Apparently this one is 1.196. I'll round it there. So this is x equals 1.196. Or my other one is the exact same thing with a minus. So I can just go up and grab that. I'm going to hit up and then hit enter to grab it. And just go change the plus to a minus. Enter. Negative 9.196. 9.196. Because these ended up with strange decimals that seem to go on forever and never end, that's why we needed the quadratic formula. These would not have factored. Every single one that factors has an answer that can be written in a nicer form. Okay, letter D is very similar except for the fact that it doesn't equal 0. It equals 3. So what if I just were to subtract 3 from both sides? So I'd have x squared plus 2x minus 3 equals 0. Now I can use the zero product property. Because it equals 0, we could factor it, we could use the quadratic formula, we have different options now. So I'm actually going to leave this one at that. This one actually ends up factoring. You can factor this one. But the key is that it has to equal 0. These quadratics use this zero product property to their advantage. So the one side of the equation has to equal 0. Similarly, I look at E and it looks intimidating because nothing equals 0. There's a quadratic on this side. There's an x squared. Over here I have to multiply stuff out apparently. So let's start there. Let's actually multiply it out. We've got 3x minus 1 and x minus 2. So that is 3x squared, 3x times x. X times minus 1 is minus x. 3x times negative 2 is minus 6x. And negative 2 times negative 1 is positive 2. So this represents 3x squared. The minus x and the minus 6x combined is minus 7x plus 2, because my 2 is positive. So I can rewrite this side of the equation as 3x squared minus 7x plus 2, and that equals the right side, 3x squared plus 3x minus 38. Now I'm looking at this and I say, wait a minute. This looks like a regular equation where I can move terms around. I have a 3x squared on both sides, So I could subtract 3x squared from this side. And if I do that, I have to do it on this side, 3x squared, both sides of the equal sign. So those just kind of drop out. That leaves me with negative 7x plus 2 equals 3x squared minus 3x squared. Those are gone. So 3x minus 38. Okay, well now I can continue doing the same thing to both sides. This is actually no longer quadratic. This is now a linear equation. If it's x to the first power, it's called a linear equation. This is no longer quadratic, so it just became much easier. Plus 7x on both sides to undo the minus 7x. The 2 comes down, so I have 2 equals 3x plus 7x is 10x minus 38. Scroll down a little bit. I'm going to add 38 to both sides. Keep my colors going. Plus 38 to undo the minus 38. That will get me 40, because 2 plus 38 is 40, equals 10x. Divide by 10 on both sides, and I would get x equals 4. There's just one solution because really this quadratic equation dropped down to a linear equation. The quadratic terms canceled out. So I just have this one solution.